As told by the founders of Tata Group, in a free enterprise, the community is not just another stakeholder in the business, but in fact the very purpose of its existence. We at Tata are working with the same philosophy. Hello everyone, this is Shivani Agarwal, currently working as a manager operation in Tata Steel Jamshedpur. And the topic of my today's presentation is maximizing the recyclicity of scrap in steel production to reduce the carbon emission. Let us begin with where India stands in terms of national carbon emission. We can see that India ranks third with 666 million tons emission per year. Coming to this graph, we can see that as per the Paris Agreement, the CO2 emission required by 2050 is from 2800 million tons to 4 to 600 million tons. At the same time, the steel demand is increasing globally. So, to achieve the target, approximately 90% reduction in the CO2 is required. So, what emission cuts had India promised? As per the government of India, CO2 emission intensity of Indian steel industry is projected to reduce from 3.1 to 2.64 by 2020 and then to 2.4 by 2030. Hence, there is an ultimate demand to reduce the CO2 emission at each stage of steel manufacturing. So, coming to my overall value chain of Tata Steel Jamshedpur plant, we get our raw material from the captive mines which we have, and this is sent to further processing to make the hot metal from the blast furnaces. And this hot metal is then sent to the steel manufacturing unit. We presently have 3 LD shops with 7 BOF converters in total. And the final product is the crude steel. And this crude steel is then sent to the mills for making the HR or CR coils and then supplied to the customer via our marketing and sales team. So at LD3 converters, we use pig iron and the steel scrap in our BOF converters as a charge mix, and the caster then solidifies this liquid steel in the desired shape. We can see the breakup of the CO2 emission here, and the maximum emission happens at the blast furnace of approximately 70%, followed by the steel making. Since the LD converter is receiving the inputs from the blast furnace itself, and so if the requirement of this hot metal is reduced, it can have a significant impact on the CO2 emission. Presently, Tata Steel Jamshedpur is benchmarking with the lowest CO2 emission in steel plants in India with 2.27 tons of generation. In LD converter, main charge mix is hot metal along with the scrap, and presently LD3 was using 7 to 8% of the scrap. So coming to the benefits of the scrap, we can see that as per the World Steel Organization, with using 1 ton of scrap and steel, production of 1.5 tons of CO2 emission is reduced. Consumption of around 1.4 tons of iron ore, 740 kg of coals, and 120 kg of limestone can be reduced. So there are so many benefits of using the scrap. Then what is the challenge in maximizing the use of this scrap in the converter? So the main challenge was the time in handling the scrap. So the magnet crane which we were using to load the scrap can lift only zero point 0.5 to 2 tons of light scrap in one lift. So to charge around 25 tons, it took around 20 to 25 minutes. But the speed at which the caster was operating was increasing over the years as the demand for the steel was increasing. So to manage the caster speed with high scrap charge was becoming difficult for us. And hence the main challenge was how to maximize this scrap charging without hampering the casting speed with the existing crane system which we had. So some of the changes were tried to increase the scrap, but it wasn't used because of one of the many reasons. So a paired comparison matrix, which involves the various criteria like safety, the cost of implementation, or the cost of maintenance, was taken care to decide which was the most suitable practice which can be used to increase the scrap charge in the vessel. Based on the paired comparison matrix, a decision matrix was made in which the weighted score was calculated for each of the available options. And we found that the orange peel grab was getting the maximum score of 147, and hence we choose to opt for this option. So installing the grab in the existing crane was a big challenge to take up, and the design study was done with our in-house crane electrical, mechanical, and operation team. And the following modification was done to install the grab. So the cable drilling drum which we were using in the existing crane was not suitable for handling the grab. So a whole new CRD was installed in the existing crane. A separate electrical panel was provided to fulfill the power requirements of the grab, and wiring and push buttons was provided in the operator cabins for the smooth operation of the grab. Next, there was the modification in the design of the scrap pan. So we found that it was not suitable for the grab, and our mechanical experts, after proper study, found that the width of that existing scrap pan can be increased by 200 mm so that it is suitable for the grab buckets. Next, we worked on the digitization aspect of the grab, and there was a time-based logic for the opening and closing of the grab was made. And after that, we finally took the trial for the grab. And with this, we were able to reduce the total time for the scrap charging by approximately 6 minutes. So before the implementation, a proper team was working on the safety aspects also. Risk assessment, MOC with PSSR was made, and required SOP were modified, and training were imparted to the operators. A daily monitoring scrap dashboard was also prepared to check the consumption of the scrap on the daily basis. And coming to my final slide, which is the most important, we can see that after the implementation of the graph, the emission intensity reduced by 4% from 282 to 271. The scrap charge was increased by average 14 tons per heat to 20 tons per heat. And at the same time, the time for charging the scrap reduced from 15 to 8 minutes. The iron ore consumption also decreased significantly, and in total, we can say that there was a tangible benefits of around 7 crores by increasing the scrap for 94 kg per TCS to approximately 115 kg per TCS. And intangibly, we were able to save the CO2 emission, we were able to reduce the resources consumption, and there was a significant improvement in the capability of our in-house team. So coming to the deployment of our idea, it can be deployed easily in our other shops of Tata Steel Jamshedpur. We have 7 converters, so it can be employed there. And taking forward, it can be done in Tata Steel Kalinganagar and Tata Steel Meramandli and all other shops across. Thank you.